We're going to look at the hex number system and understand why we use it in computer science. So if we took this number and I said to you, I'd like you to memorize this, I'm sure you could memorize it, but it would be difficult to remember over time. I can show you an easier way to remember it. If I were to group these binary digits into 4s and give them a different number or letter, I'm going to give them a 6E5F. I'm going to put them into pairs. So if I said to you, can you memorize 6E5F and tell me what it is tomorrow, I think you'd have a much better chance of getting it right than the binary number. So we just need to understand, how do we get to 6E5F? When we converted binary to denary, I hope you might recognize that 0110 actually is 6. Remember what we would do if I asked you to convert it? You'd put the table at the top, 1, 2, 4, 8. You'd add up the numbers that have a 1 against them, and lo and behold, 4 plus 2 is 6. We've got the same thing here, 1, 2, 4 and 8. 4 plus 1 is 5. The bigger numbers have been turned into letters, and that's because the hex number system uses letters to represent numbers between 10 and 15. Let me show you. What should this number be if I asked you to convert it to denary? Well, it would be 8 plus 4 plus 2, which would be 8, 12, 14. And indeed, F would have been 15. I don't want you to write 6, 14, 5, 15. The hex number system goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But instead of 10, it shows an A. Instead of 11, a B, 12, C, 13, D, 14E, 15F. So now you can see when we converted 1110, we converted it to 14. I then looked at my table and 14 is worth an E in hex. So why are we doing all this? Hex is easier to remember, easier to read, less likely to make mistakes when you are writing in hex. In an exam, it might ask you what are the advantages of writing in hex. A lot of students write in the exam that because they've written 6E5F, it's taking up less space on the computer. But it isn't really, because 6E5F is just a translation of the binary that is really being stored.